will never able to get access to all the things. So it is that's why impossible to change the hash codes at a time because it's very dynamic. And some time back I was talking about this P2P network, okay, peer-to-peer network. So you have to be in a network so the blockchain to work. So this is a network of nodes where this blockchain is created at this node. So it will what it will do, it will be shared across all these um, say stakeholders or nodes. They will maintain the same copy, and then if a new node is added, that node of course after this validation from each of the other parties, it will be shared across all. Okay, so a basic idea on cryptographic, that cryptography works on the public key and the private key. Okay, so one needs to have this private key in order to access the blockchain, and if you lose this private key then you will not be able to access your own content. Okay, so that is essential. And um, yeah, so this point is very important. I wanted to tell that public keys can't help to bring private key. If you have the private key you can always create the public key, but if you have the public key, I mean that's how blockchain is secure, because public key can get accessed. Okay, and if it gets accessed by intent, then likelihood that they would access others. Okay, they can't, because a public key cannot be used to create private key, but the private key holders who are in the network, they can if required generate back the public key, and that is typically how the SHA 256 works. Now coming to this consensus protocol, because as you might have observed by now that all this whole blockchain idea is relied upon this consensus protocol. Now what is this protocol? Now protocol, I'll just give an analogy here. So you are a group of 10 friends, okay, and this is a Sunday, I mean a weekend evening, and you want to go out. Now there are two ways that two ideas have come up: one to go for a dinner, or to go for some recreational activity to some park or something. Okay, now the group is getting divided, like two different views. Some wants to go there, some wants to go there. So what to do? Because everyone should go together, all the 10 friends should go together and enjoy. So the obvious algorithm that you will come across is that take a vote. Okay, let's go for a voting, and the majority, if they say for dinner, then we'll go for dinner, otherwise not. Okay, so but here, like if I am among that 10 friends, I realize that I want to go for movie and not others are interested to go for movie. So what should I do? So I will call some of my more friends to support me in that voting. So the point of telling is that there is a chance of getting manipulated. Okay, so now what is proof of work? Now not all. Okay, and I need a majority, of course. So out of 10 friends, majority will be 6, right? So I will design 6 problems, 6 puzzles to solve, and whoever solves first gets a chance to speak out. Okay, so that is typically how proof of work works. In the blockchain scenario, it works like whoever has the maximum computational power, okay, so they get a chance to validate. Okay, so they, because they will be able to solve the problem, because this proof of work means it will throw a computational problem and all the stakeholder will solve that problem, and then whoever solves faster gets some reward, some credit. Okay, and typically in the Bitcoin and the cryptocurrency scenario, it is money is involved, but anyway we can always design our work, instead of money we can involve something else, some credit point, something. Okay, so in this friend scenario, so what happens is that a solving problem puzzle is given, whoever solve first comes up and gives his views. So there, though manipulations can happen, but chances are less. Okay, and each of these mechanisms have its own pros and cons. Then what is proof of stake? Proof of stake means that instead of solving puzzles, because what is the difficulty in solving puzzles? In a blockchain scenario, it requires more computational power. More computational power means more energy, more electricity used, more resources are required. High-end systems are required to solve computational problems. Okay, so that becomes a difficulty. So to simplify that, what is said that okay, now all these friends what they will do, they will give some money. Okay, and whoever gives more money will have the maximum stake. They will go first to give the voting whether to go for dinner or recreational activity. So now the problem, the same scenario applies here. So you, what you do in proof of stake, you buy some, you give some money, you put some money. Okay, and if you are found fraudulent or manipulative, then your money goes off. If not, if you are correct, this is validated, this block or transaction is validated, then you get a reward. Okay, and how to ensure that this is okay and people are not manipulating? Because the punishment or the penalty will be high. It's a real money involved in this, in the scenario of Bitcoin. So so now here in the case of say example this mark entry. Okay, now what can be at stake? Something like, if not money, could be money, like salary will be deducted. So nobody will dare to do any manipulation. Okay, rather than the benefit, the punishment or the penalty will be more severe, or job will be gone, something. Okay, so that is proof of stake. Same scenario here. And apart from this proof of work and proof of stake, there are many other consensus protocols as I have listed here. You can explore more on this, and you can come up with your own design also. Okay, so like in that case, both problem solving will be there and money will be there. Like whoever wants to, not everyone would be wanting to solve the problem to vote. Okay, but some else would be there. So each and every friend would donate some amount of money, let's say 100 rupees each, in order to participate in the problem solving, and whoever wins gets all the money, and others lose the money. Okay, so this is a combination of proof of work and proof of stake. So like that, you can design your own consensus protocol depending upon the case study in the, like the application area, right? um, yeah, so you can explore this. And anyone who wants to dive deep into this blockchain applications, the first thing I'll suggest is that make a thorough study. Okay, of each of these algorithms. Okay, to pick up a case study, and in the context of that case study, see which one of these would work best. Okay, you find out, analyze the pros and cons, and you can also publish a paper on this. Very nice paper can be published on this. Okay, on different scenarios, different case studies, which one would come best. You can make an analysis and work. So huge scope here to explore. And even if you are not going to the research line also, but to understand this thing also, you need to have an analytical study, detailed study of all these algorithms. Then only you will be in a position to take a call, because as you know, blockchain starts with consensus protocol. Okay, there is some difference between the proof of work and proof of stake, which I have explained in terms of an analogy. Here it is in the terms of a blockchain scenario. Now, how does this blockchain work finally? So a transaction is requested, the first step. Okay, that block of transaction uh, goes to all the stakeholders. Okay, every node in the network, and then through some consensus algorithm which we discussed, the nodes are validated. And it's not always possible that everyone will validate. Okay, though it's normally stated that all the nodes validate, but it will never happen ideally. So we go for a majority. Okay, that's why I was talking about majority voting here when I was talking about proof of work and proof of stake. And then receives the reward for that. Mostly the monetary rewards are involved here. You can plan any other reward as you like. And then finally the block is added, and the transaction is complete. So this is a typical activity that will happen in any blockchain scenario. Okay. So these are some of the basic components of any blockchain system. That this is the distributed ledger. Okay, that's a database kind of thing that is stored. Okay, which is shared across. And then there is a smart contract. Smart contract, as I said, it's an agreement. Like if some service is guaranteed, if that doesn't happen, then what is the penalty involved, and other terms and conditions. Like for example, the best analogy I can give here is that um, you have booked a flight ticket, okay, to travel from say Bhubaneswar to Bangalore or some other part of the world, okay, and mostly there are chances that this flight gets delayed, and when the flight gets delayed, the company from which you have bought the tickets, they promise to pay certain money, okay, as a penalty. Now, in order to suppose you are going to board a flight at 4 p.m. and it gets delayed by 2 hours, so your 2 hours of time is wasted. You may uh, miss out the connecting flights and so on and so forth. So now, how to get back that penalty amount because of the flight delay? Now you will produce lot of documents. It will go through lot of scrutiny. Okay, and then after 6 months or a year, you may get that amount. But if that whole process is implemented through this blockchain, through the smart contract, then what smart contract will specify? It will specify that it will automatically detect, because it's in that blockchain, that the flight got delayed. Once it detects, it will trigger this contract. Okay. And automatically the amount that is to be deposited or given to you would be deposited in your account. So within a fraction of second, the moment the flight delay is announced, you will get your money in your account. So that is the beauty of this smart contract. So it's agreement. Again, you have to code it. Okay, you have to develop your own smart contract. Though you will get many, say what you call that, formats. You can follow formats. You need not do it from scratch. But you can always design your own smart contract, as you can design your own consensus algorithm, which we have spoken about. And the node application, of course, in order to be able to use blockchain, like all those cryptographic algorithms and all those connections. Okay, you need to have a client in your system. I mean, in my computer system, I want to implement a blockchain. I want to be a part of the network. To be a part of the network, I need to have all those softwares that is required to create a blockchain and proceed. Again, I'll speak something on that also quickly. So this is the whole idea of blockchain. So, Mitra madam, Bina madam, if you are there, so I may exceed by 5-10 minutes. Is that fine?
Yes, yes, sir. If you want, you can.
Okay. I hope the
Taking
students
five
are
to
not
ten minutes
getting.
for question answering. Yeah, the students, if they have any doubt, they can ask the question. Yeah, just you give the application in help. Yeah.
Yeah, yeah. So we'll go there. So that's why I'll slightly take 10 minutes more, maybe.
Yes.
Yeah. So now I'll come to this. I was talking about the node application, right? So how to get started with a blockchain if you want to. So all that you have heard me is that stories that I have told about blockchain. Okay. Now how to get started. Now this is a typical implementational details of the Ethereum network. So if you are using Ethereum, you can use Hyperledger. You can visit Hyperledger is initiated by IBM. So if you want, you can visit their website and get lot of details how to get started on Hyperledgers. This is about Ethereum. Okay, so Ethereum you require this Web3.js. You'll get enough of material to study and learn about this. And this is the like a GUI interface to get started to create node and do all this stuff. Okay, so yeah, the smart contracts I've already talked about, so I'll skip. It was coined by this Nick Szabo. So this is Ethereum. What happens here is that user navigates to the website, okay, inputs his or her Ethereum address or email, of course you have to have an account with that. That's why you need to download and have this set up in your system. Okay, and then uh, the website would request to the authentication server for authorization. Authentication server will again connect to this account Ethereum cloud to get the authentication to validate. Okay, and then that will send us a request to this to validate the request. Then there's mobile sorry this user or owner of that Ethereum account, which probably you or me or someone else, okay, gets this authorization message, and then uh, the user approves that request. Okay, it could be like a OTP or something, if I have to say. And then this application authorizes, gives it back to the authorization server, which returns back to the website confirming the login. Okay, so this is all activity will happen when you try to use Ethereum. Now, Solidity is that language that is used to develop the smart contracts. Okay, so this is a typical look of the Solidity language. Again, there are enough material, open source materials. You can learn this Solidity programming if you are acquainted with object-oriented programming, any language, C++, Java, whatever. So you can quickly learn. So I'll not also go into that details. So I'll just quickly skip through. Then private blockchain network. This is a typical example of how to create a private blockchain network using Ethereum. Okay, so it will allow you to create virtual machines, okay, in the Ethereum environment, wherein each virtual machine you can designate as a node, and that node would run a copy of the entire blockchain. Okay, all those nodes that we were discussing about the distributed scenario, you can do it in your own system also, and that's what this typical example uh, thing. Okay, so this is a smart contract example that we have built just for money withdrawal balance and all that to designate a transaction. Okay, um, and the Solidity is advisable that you use these versions 4.22 to 0.6 for better performance. So these are the steps which you can follow to get started with Ethereum blockchain. Okay, you have to install this Geth, then configure the Genesis, that is the starting block, then create some local nodes, make some initial accounts, initialize and start the nodes, connect to each node, and from the command line, interconnect the nodes, send some Ether. Ether means the feedback reward. Okay, so this is some introduction to Geth, that is the command line interface. So you can go through this, nothing more. So this is the link from where you can get all the informations, downloads to get started. Okay, this is the typical setup that we have had. So this is the Genesis block. You can see all these blocks are initialized to zeros initially. The typical block would look like this in the Ethereum scenario. Okay, then we are creating 3 new directories as separate nodes. Okay, that node 1, node 2, node 3 through a simple make directory command in that command prompt. Then we are creating this initial account, okay, through this command. Then we are initializing each node with this file, because each node will have all these files connected. So that is done through this command. You can do this. Then you can connect to each node from the command line by giving these commands mentioned here. Then you interconnect those nodes, port numbers and all those details. Okay, then 2 accounts created for performing transaction on private blockchain. So this is for this demonstration typical example shown. You can create as many as you want to, not an issue. Okay, so I quickly hurried you through this. So because unless and until you go to this site and download and get started, you will not make any sense. Okay, though I have put these slides for your reference, I'll share this slide also, you can get started. So you have to go there, and then you will get to know. It's a simple thing, it's not a big deal. You can get started. Now coming to our healthcare case study, like how it applies, how it relates to that. Before it go, we go to the how. Let's first spend some time on why. Okay, why healthcare? What's the problem? In India, we don't realize the importance of having a blockchain application of all the healthcare records. Okay, but this time that we should have started this, because say you have a health insurance. Okay, now you suddenly got infected with COVID-19. Okay, then you were hospitalized, or so any critical disease you hospitalized. Okay, now the hospital does not have a collaboration with the health insurance provider from which you have, or from the other side, the insurance company may get cheated with fake documents, fake things. Okay, now there is a huge need to avoid all these things. Apart from that, now in this COVID scenario, if we had a normal fever also, we went ahead and went for testing, like not just COVID but other vitals. Okay, we got tested for our blood pressure, for our blood, different tests were done, and we were given this report card. Okay, all is normal, fine, but what happened to those data that was generated? So those data are sold to whom? To pharma companies, to research organizations, to researchers like us, okay, who are working on medical analytics. But what do you get out of it? This is your data, your blood, everything is yours, but you don't have a stake in that, right? So that is why uh, in Europe, this General Data Protection Regulation (GDPR), okay, it gives certain rights to the individual in this context, in this scenario. What are those? The right to know exactly how your data is collected and used. Okay, and to make things more complex, you might be using many these smart watches, many other equipments nowadays. Okay, and you would not be knowing that your data is sent to some cloud, some storage somewhere. Okay, and what's happening with that? So you have a right to know that how this data is collected, not necessarily through the testing laboratories, but across, as the on the slide you can see the figure, through many devices your data is getting stored somewhere else. Then the right to ask what information has been collected about you, the right to correct data errors, the right to delete data from records, the right to refuse data processing. Okay, recently you might have known that this cholesterol. Okay, in the name of cholesterol, HDL and LDL, that is good cholesterol and bad cholesterol, a huge business was set up, starting from the pharma companies to many yoga gurus to all. Okay, Ayurvedic products, lot of people made good business on the fear that your cholesterol is increasing, you will have an increased heart attack chances, so you have to do all this thing activity, including many apps are there. Even I'll tell you, I'll not name that insurance company name, which insists that you download an app and you work this much of day, otherwise your what this claim amount will get reduced because you are not working out. And so I had a little argument and fight with that company, but anyway, so all these things happen. So that needs to be done, taken care of. Then the right to delete data from the records, the right to refuse data processing. And another problem is that now for some disease you are in Bangalore, and for some disease you are going to a doctor. Now the doctor would ask you thousands of questions about your history if he is a good doctor. Otherwise, he'll just prescribe some medicine and you will eat, and that's not. But in order to diagnose the proper cause of the disease or the problem or the medical complication, one needs to know the entire history. Now you won't be carrying your entire history of medical records. Okay, in your, I mean, if you are 22 or 24 years of age, then you might have visited so many doctors who so many doctors have might have prescribed so many medicines, and this current problem could be a side effect of all those medications that you have gone through. Could be. Like, how to know that, how you get that information. So all this thing will be addressed through blockchain. Okay, now blockchain, you can authorize the doctor will log into the blockchain link. They will get all the historical records, wherever, which hospital, whatever medications are given, should get to know, so that the diagnosis can be more correct. Okay, so because of this false diagnosis, lot of people die, or become seriously ill, become paralyzed. So many things happen because of this. So the current challenges in healthcare, that is no remote access. Okay, like in the COVID scenario, you might have seen. I think most people have died because of other problems than corona. Okay, whole attention was on corona, and other treatments were what compromised. Then issues with medical reimbursement, which I have talked about. Uh, Manage massive volume of patient related records. So much of data is getting generated each moment. So how do you store it? Where do you store it? Okay, I said that it should be stored, but how? That is a challenge. Then inefficiencies and errors in data sharing, lack of online medical stores and efficient drug delivery system. Okay, so this is the problem that you might have observed, that your doctor has prescribed some medicine and you are searching around the city uh, to find that medicine. Okay, or you are on some medicine for a long time, like you are asthmatic, you are taking certain inhaler, but you land up in a city where you don't find that, or the drug is banned, so you don't get that composition. What do you do? So all these things can be taken out, and these are not in single blockchain implementation. This is a like a delivery line. There is a good word for that. I'm missing that. Anyway, I'll come to that. So supply chain management. Yes. So this is for supply chain management of the drugs systems. Okay. And the compositions. Like now we realize that generic medicine costs so less. But how do you know what the generic medicine is for the particular drug that is prescribed to you? So all these things can be addressed through this blockchain application. And these are some of the things that improper disposal of medical things, records, equipments, in the loss of records, theft, unauthorized access, hacking, IT incidents. These have been taken from this paper too. Okay, so you can see all this hacking and IT incidents. You can see the largest, 81%. So this will be avoided because through blockchain, because blockchains are tamper proof. So what are the blockchain based healthcare applications? Okay, as I was saying, healthcare does not mean just record keeping of the prescriptions and medical reports. It's a huge, like health insurance, remote patient monitoring, that we call telehealth services. Okay, and drug um, management and pharmaceutical companies, their games are different level. Then industry based research projects, like people like us and the industry. Okay, we also depend upon this data, patient data management, electronic health records, and all these things. Okay, so each of these challenges, I mean, if anyone is interested, it has huge scope to apply, especially in India. I'll come to that India scenario also. What is the scope? So why blockchain in healthcare is required? Already I have spoken about it elaborately, but these are the few points. Decentralization, immutability, transparency we require, open access. In India, the transparency is not there actually. Auditability and anonymity. Okay. So what are tele healthcare services? So these are patients outreach. Okay. so that the patient can conveniently, like sometime back, our prime minister said that the patients need not come to hospital for treatment. Treatment should reach the patient. How will that happen? Okay. So this is only through this online medium. Okay, online medium patient means the doctor will not be able to see your pulse. Then how will the doctor know that how what kind of a diagnosis to be done? Okay, for that again IoT devices needs to be linked. Where this in the first slide I had shown that devices sending data. Okay, those devices and those data will be stored so that the doctor can access those data and make a good diagnosis. That's a huge challenge. Then effectiveness. Okay. Um, First thing is the getting the say appointment of the doctor. Second thing is the diagnosis correctness. Then convenience. Okay. For long term, like there are many diseases that requires long term medication and care. How to do that? Okay. Then the output or the throughput or the performance. Okay. Then workforce limitations, minimize patient access and workforce limitation issues. Diagnosis time, it needs to be faster. Currently, it's very slow. So you give your blood and then in the evening you will get your report. So that thing will be faster. Then social distance will be maintained, and of course revenue. And it's a win-win scenario for all. Nobody is at loss. So it will give rise to huge revenue. To this revenue thing, I'll show you an interesting slide. Now this is the solution. Okay, the case study. So how this blockchain implemented, how it will work. Okay, of course you need to develop smart contracts, and it cannot be a generalized smart contract. It for each and every activity that you have seen here. Sorry, here for different smart contracts to different hospitals, different scenarios needs to be taken care of. Okay, so this is the health authority. As in the initially, I had shown that in the registration, the authority was taking control of that. And this solution is only for that, so that health authority is not aware of what's happening in the health scenario or health sector. Now through this, we can know. So what are the list of banned drugs? It will be communicated to all the stakeholders. Okay, what are this health alert, what are the update on health data, what are the reports, everything is connected in this decentralized storage system. And this blockchain network uh, is storing all those references to all these storage systems, and these are all guided by this consensus protocols and the smart contracts. Okay, so these are some potential benefits which you probably I'll skip. But challenges are there many, like organizational challenges to adoption of blockchain, because you require resources, setups, okay, uh, data centers to store the records and all that. An enormous amount of health data and increasing transactions fees. So the challenge here is that health data will be in different forms. Okay, need not be necessarily in textual form. It could be X-rays. It could be many other what do you call that? Those radiography films will be there. So they need to be digitized and stored. So that is involves a lot of challenge. Then of course security vulnerability of smart contracts. Okay, the whole thing is smart based on smart contract. But what if smart contract is compromised? Okay, so we need to think separately to ensure smart contract. Blockchain ensures this other part also, but blockchain is dependent on smart contract. How to ensure smart contract, that's again another challenge. Okay, and this could be a good research domain. If anyone wants to pursue a PhD, can do so here. Okay, security of smart contracts. Yeah, this is an interesting say motivation to explore more on healthcare, blockchain application on healthcare. So here you can see this is a recent study, like 60% of healthcare organizations are considered prime targets for cyber attacks. 75% of healthcare organizations are unprepared to handle cyber attacks. They don't even realize. and 90% of remote healthcare workers have not received updated training. Forget about training, I have not heard about it also. That such and such problems can happen. Okay, so are not even aware of, like in India, um, Apollo has started on blockchain work, but not many are there. Okay, so this is some more details on the cyber security and the descriptions. Yeah, this is what the interesting slide I was talking about. What is the chances in terms of money? Okay, so as I said, you can, someone interested after graduation to have a startup can have a startup. Like a simple example, I said we all booked air tickets. We all pay extra money that will get refunded if there is a delay. Okay, but nobody claims that. Okay, because of the hassle. If you can come up with an startup that offers a blockchain solution, then trust me, you'll be an instant hit. You don't have competitors right now. And if see, though US and China will be making money, India is lagging behind. By 2030, India's tech compared to US and China will be so less than this $100 billion. Okay, there is a huge scope that we can work forward on this. Yeah, so on this, how much money can be generated by 2030 in India only? You can see securitization and payments 13.2, agreement threshold and disputes 1.2, loyalty and rewards 1.6 billion. So there is huge scope in terms of money. If not for startup, at least for research also there is huge scope. Okay, so I'm almost done. This is the conclusion. Uh, these are my references which you can follow for a better understanding, because I had to run through quickly on some of the contents. Yeah, we are done. Ma'am, if any questions, I can take up. And if anyone
Thank you,
has thought of
Subrata.
any case
If
study, also
anyone having
can
any
tell me.
question, if anyone having any question, please ask.
May I ask a question, sir?
Yeah, please go ahead.
Sir, actually, sir, you were talking about 1,000 notes.
Uh, no, why do you require there's 1,000 nodes?
Sir, actually, sir, for case study, I am taking the diary from diary.
Right.
Yes, sir.
But why 1,000 nodes? Like for storing some information or what? Or you
Yes,
just
sir.
need to connect
That means, sir,
the
multiple farmers will be there. Suppose to 1,000 farmers will be there. They will have their own cows, and I need to consider each farmer as one node. Actually, I am talking about the idea, but I don't have the clear idea regarding that. That's what I'm asking.
yeah, this scalability is always a challenge in blockchain. Okay. But the scalability, there is, I don't see any challenge in why you cannot form 1,000 nodes. But if some platform you have tried is not allowing, where you can look for Ethereum and Hyperledger.
Okay, sir.
But storage is a challenge.
Okay, sir.
Okay,
And
thank you.
also you try to go for cloud application. Try to link with cloud virtualization, where you can create unlimited nodes.
Okay, sir.
Thank you. Thank you, Subratan, for giving your valuable time. Thank you,
I have
BTech
a question.
students, MTech students, and our research scholars. Thanks, everyone. I hope all of you gained something from this. For BTech students, I said that you concentrate on the programming part. Okay, that will
Yeah,
help
but that's
you.
the main challenge. Actually, ma'am, you rightly said that's the main challenge. The smart
Yeah.
contract development. That is the real challenge.
Thank you all. Because we're out of the time. Let's stop here. Thank you everyone for doing this.
I hope I was well received. So I thank you, ma'am, and all others for facilitating this talk and for having me. Thank you so much.
हो मी गाणं तुम्ही चिंता कोणतरी चालू
Ma'am,
ମୁଁ ଦୁଇଟାରେ
can we
କହୁଥିଲି
sign off?
ବାହାରିବି, ମୋର ବି ତ କ୍ଲାସ୍ ନଥିଲା, ଘରେ ବସି ପଢୁଥିଲି ବସିକି।
Okay, let's end. Thank you all.
Ma'am, shall I sign off?
Yeah, please.
Okay, thank you. Bye.
Thank you.